me teach you sp2 hybridization. sp2 hybridization means that in this mixture of atomic orbitals, there is one s orbital and two p orbitals. Hence, there are total 3 orbitals present in sp2 hybridization, or there is 33% s character and 67% p character present in sp2 hybridization. Now, how these orbitals 1s and 2s combine together in sp2 hybridization? Well, again consider carbon in a ground state. We know that 1s has 2 electrons, 2s has 2 electrons, and in 2p, there is 1 electron in x orbital and 1 electron in y orbital. While in excited state of carbon, 1s has 2 electrons, 2s has 1 electron, and in 2p, there is 1 electron in x orbital, 1 electron in y orbital, and 1 electron in z orbital. Now, in the hybrid state, there are already 2 electrons present in the 1s orbital. We know that in sp2 hybridization, 1s orbital and 2p orbitals combine together. So this 2s orbital, x and y orbitals of 2p would combine together to form 3 orbitals of sp2 hybridization. Thus I will put these unpaired electron in these hybrid orbitals having same spin. This is the first sp2 orbital, this is the second sp2 orbital, and this is the third sp2 orbital. Lastly, I write this z orbital of 2p here. This z orbital is unhybrid orbital. It means that this z orbital do not combine with 2s, 2px and 2py. Also, it has more energy than all these 3 hybrid orbitals. Now, carbon has this type of geometry in sp2 hybridization. This is the first sp2 orbital, this is the second and third sp2 orbitals. While this long orbital is the 2pz orbital, which is unhybridized orbital. These all orbitals have 1 electron each. Remember that the bond angle in sp2 hybridization is 120 degree, while the shape of carbon is trigonal. Also, let me give you an example of sp2 hybridization of carbon in a molecule like ethane. Let's consider sp2 hybridization in this carbon atom and in this carbon atom. Firstly, both the carbon atoms will form chemical bond by sharing the unpaired electrons in these sp-sp orbitals. Secondly, they both will share the unpaired electrons in the unhybrid orbitals 2pz. Then hydrogen will share its 1 electron with this sp2 orbital and with this sp2 orbital. Also, hydrogen will share its electron with this sp2 orbital and with this sp2 orbital. Note it down that unhybrid orbitals always form pi bond. For example, this 2pz form pi bond, while hybrid orbitals always form sigma bond. For example, these sp2 orbitals form sigma bond. Thus, in ethane, there is 1 pi bond and 1 sigma bond between carbon-carbon atoms. Hence, this is the shape and geometry of a molecule in which carbon has sp2 hybridization. So, note it down this example. Finally, let me teach you sp hybridization. sp hybridization means that in this mixture of atomic orbitals, there is 1 orbital of s and 1 orbital of p present in it. So there are total 2 orbitals present in sp hybridization. There is 50% s character and 50% p character in it. Now, how 1s orbital and 1p orbital combine together to form sp hybridization? Well, again consider carbon in ground state and an excited state. We know that in sp hybridization, only 1s and 1p orbitals mix are combined together to form sp hybridization. Hence, in the excited state, 2s orbital and only x orbital of 2p combine together to form 2 sp hybrid orbitals. This is the first sp orbital and this is the second sp orbital. The y and z orbitals of 2p do not take part in sp hybridization of carbon. So they both are unhybrid orbitals. Thus we have 2 hybrid orbitals in sp hybridization, each having unpaired electron. Now carbon has this type of geometry in sp hybridization. This is the first sp orbital and this is the second sp orbital. While this long orbital is 2py and this long orbital is 2pz. They both are unhybrid orbitals. The bond angle of sp hybridization is 180 degree and its shape is linear. Also, let me give you an example of sp hybridization of carbon and a molecule like ethane. Let's consider sp hybridization in this carbon and in this carbon. Firstly, both the carbon atoms will share the unpaired electrons in sp-sp orbitals to form a chemical bond. Secondly, they both will share the unpaired electrons in unhybrid orbitals like 2py and 2pz to form a chemical bond. Then hydrogen will share its one electron with this sp orbital and with this sp orbital. There are two unhybrid orbitals like 2py and 2pz joined between carbon atoms, so there are two pi bonds present in ethane. While there is one hybrid orbital joined between carbon atoms, so there is only one sigma bond present in ethane. Hence this is the shape and geometry of a molecule in which carbon has sp hybridization. Thus noted down this example.